1 over square root of 3 minus 1 over square root of 6 and 1 over square root of 2 with respect to the fixed frame x, y, z. Suppose that P is rotated about the fixed frame x by 30 degrees, then about y by 135, and finally about fixed frame z by negative 120. Okay, so we're gonna have point 1 over square root of 3, negative 1 over square root of 6, and 1 over square root of 2. And we're going to do 3 rotations on it. And for that, we're going to use a rotation matrix. Rotation matrix. Let's do a copy and paste. Let's grab. So for x, y, z in 3 dimensions, these are the 3 rotation matrices. So it makes sense because like x is just all zeros except for the x where it's 1, and then you have the same thing for y and z. So we're going to do 3 rotations. We're going to rotate. So we're going to do point P. We're going to rotate x direction by 30 degrees, which I'm going to write as pi over 6. Then we're going to do rotation about y by 135 degrees. So 135 is this direction. So that's going to be, this is 45 degrees, which would be pi over 4. This is going to be pi over 2. So pi over 2 plus pi over 4 is 3 pi over 4. So I'll call that 3 pi over 4. And then we're going to do about the z-axis of negative 120. So negative 120 is going to be pi over 2 here. That's going to give 30 degrees over here, which is going to be pi over 6. So pi over 2 plus pi over 6. I'm just converting things to radians. I don't have to. It's just that I prefer radians. So this gives us 3 pi plus pi, which is 4 pi over 6, which is 2 pi over 3. Yep. Negative 2 pi over 3. And I'll come back to them when I do them again. All right, so game face, focus. So I'm going to do the first rotation. We're going to write the rotation matrix. Actually, I'm not going to rewrite it. I will rewrite it. So the first part, this will be part 1, part 2, part 3. So for rotation 1, we're just going to do them in order. So I'm going to write up our matrix. 1, 0, 0, 0, cosine pi over 6. Nope. Everything is too close together. Poor planning. All right. X direction first. 1, 0, 0, 0, cosine pi over 6, negative sine, also pi over 6 because that's the angle we're rotating by. 0, sine pi over 6. You can see why computers are so good at this. Cosine pi over 6. There we go. And we look at, and then we're going to multiply this by 1 over square root of 3. Probably should make sure I do a better job writing that because this is going to be an accounting problem. Basically making sure we don't drop any. We do a whole bunch of simple calculations correctly. All right, so this is a 3 by 3 matrix. This is a 3 by 1 matrix. Their numbers in the middle are the same, and it's going to result in a 3 by 1. So the first term, should I yeah, I should rewrite this. So it's going to be 1, 0, 0. I'm going to write up. This is pi over 6. That's going to give us a value of square root of 3 over 2, 1/2. So pi over 6, the cosine of pi over 6 is square root of 3 over 2. That's the x value. And the y value is going to be 1/2. So I'm just going to put that in real quick. So we're going to have 0 square root of 3 over 2, negative 1/2, because negative of 1/2, 0, positive 1/2, and then square root of 3 over 2. And we're going to multiply that by our point up here. Copy, paste. Make it a little bit bigger, just so everything matches up. All right, and that's going to equal our 3 by 1 matrix. All right, so now we're going to look at the first term. So it's going to be row times column. So 1 times 1 over square root of 3 plus 0 times 1 over square root of 6 plus 0 times 1 over square root of 2. So we're going to have 1 over square root of 3. Okay, seems reasonable. Next one, we're going to have 0 times 1 over square root of 3 plus square root of 3 over 2 times negative 1 over square root of 6 plus negative 1 over 2 times 1 over square root of 2. Yep. And simplifying this, so square root of 3 over square root of 6, that should be simple. Negative 1/2. Oh, so I'll write this. Actually, I'm going to do this a little bit differently. Negative square root of 3 over 2 square root of 6 plus plus negative 1 over 2 square root of 2 times square root of 3 over square root of 3. Square root of 2 times square root of 3 becomes square root of 6. And it's doing common denominator here. So we have negative 2 square root of 3, because we have 2 negative square root of 3's, times 2 times the square root of 6. The 2's cancel. We have negative square root of 3 over 6, which is equal to negative square root of 1/2, which is negative 1 over square root of 2. I know. Lots of algebra, lots of math, very prone to error. That's going to be part of the game here. All right, so then in the next one, we're going to have 0 times 1 over square root of 3 plus 1/2 times negative 1 over square root of 6 plus square root of 3 over 2 times 1 over square root of 2. That looks like a pain. Negative square root of negative 1 over square root, yep. Square root of 3 over square root of 2. Okay, that's okay. We could probably do this, maybe. So we want common denominator. Oh, yeah, we just do square root of 3 on the bottom. Times square root of 3 over square root of 3. So this gives us negative 1 over 2 square root of 6 plus 3, because square root of 3 times square root of 3 is 3, all over 2, again, square root of 6. And this gives us 3 minus 1, which is 2. 2 square root of 6. 2's cancel, and we get 1 over square root of 6. Yep, there we go. I'm good at that. And so then this becomes 1 over square root of 6. So yes, we're good with that. So that's the first rotation. I know, this one's going to be a bit of work. So now we have on this, look at the next one real quick. So for the next one, it's going to be 3 pi over 4. So I'm going to grab this, copy, paste 3 pi over 4, and I'm going to make a copy of the rotation. So now we're going to have cosine of 3 pi over 4, 0, because we're going y direction, sine 3 pi over 4, 0, 1, 0, negative sine 3 pi over 4, 0, cosine 3 pi over 4. And we're going to multiply this by our new point, which we just got, which is up here. Whoop. Get rid of that. There we go. And then we're going to simplify this. So cosine of 3 pi over 4. So we're going to do, so 3 pi over 4 is this direction. So that's going to give us negative square root of 2 over 2 for the cosine value, and then square root of 2 over 2 for the sine value. So this is going to be negative square root of 2 over 2, 0, square root of 2 over 2, 0, 1, 0, negative square root of 2 over 2, because negative of the positive, 0, negative square root of 2 over 2. And again, we have a 3 by 3 matrix times a 3 by 1. The middle numbers are the same, so we can do it, and it's going to result in a 3 by 1 matrix. So this will be a 3 by 1. So we're going to do the top row first. So we're going to have negative square root of 2 over 2 times 1 over square root of 3 plus 0, 0 times negative 1 over square root of 2 plus square root of 2 over 2 times 1 over square root of 6. So to make this a common denominator, we'll do multiply this by 1 over here. And by 1, I mean square root of 2 over 2. So we got square root of 2, square root of 3, and 2. Yep. So the top part, square root of 2 over 2, becomes negative 2, because square root of 2 times square root of 2 is 2. Negative is negative 2. So we have negative 2 over 2 square root of 6 plus square root of 2 over 2 square root of 6. And this gives us negative 2 plus square root of 2 over 2 square root of 6. That doesn't look as pretty as I'd like. Yep, I don't think it can be helped. All right, and then, so that's going to be the first term. Oh, put this up here. The second term is just going to be 0 times 1 over square root of 3. 1 will be negative 1 over square root of 2 plus 0. So that's going to be negative 1 over square root of 2 over square root of 2. Now for the third term, we're going to have negative square root of 2 over 2 times 1 over square root of 3 plus 0. 0 times negative 1 over square root of 2 plus, let's see here, negative square root of 2 over 2, yep, negative square root of 2 over 2 times 1 over square root of 6. All right, so to get this to work out again, we're going to again do square root of 2 over square root of 2. This gives us square root of 2, square root of 3, which gives us square root of 6 times 2. So this top part gives us, again, negative 2 over square root of 6, or 2 square root of 6. So this gives us, yep, negative 2 times 1, square root of 6, minus, I'll do plus, minus negative square root of 2 over 2 square root of 6. And this gives us something very similar, negative 2 minus square root of 2 over 2 square root of 6. Okay, seems plausible. Rewrite this 2 so I get less likely to get confused when I look at it again later. All right, and then I'll redraw the brackets for our matrix. All right, so that's going to be the Y rotation. So now we're going to come down here and do the Z rotation. Oh, so this is going to be our new point. And for the Z rotation, copy and paste our little cheat sheet right here. So we have it available. For the Z rotation, we wanted to do, let's see, negative 120. So I'm going to draw out unit circle for negative 120 right here. So that's pi over 6, which is the same as pi over 3 from that side. So this is 60 degrees. This is 120 because that's 90 and 30. Yep, I'm good at that. And so this point right here, if we look at it from pi over 3 side, that's going to be, the cosine is going to be negative 1/2, and the sine is going to be negative square root of 3 over 2. There we go. And so then our rotation matrix for Z is going to be the cosine value, which is negative 1/2. the sign value, negative the sign value, which is going to be square root of 3 over 2 because it's negative, negative, 0. The sine value, which is negative square root of 3 over 2. Cosine value, which is again negative 1/2, 0, and then 0, 0, 1. Okay. So again, 3 by 3 matrix multiplied by 3 by 1 gives us a 3 by 1. So we're going to have negative 1/2 times negative 2 plus square root of 2 over 2 square root of 6. And we're going to add to that square root of 3 over 2 times negative 1 over square root of 2. Does that make things easier? I don't know if it does. So we have a 2. We're going to have another 2. So we're going to multiply by 2 over 2. And we need a 3. So we're going to multiply by square root of 3 over square root of 3. So this gives us 4 and square root of 6. Okay, so now they should have common denominators. So this is going to be the negative 1 up top is going to make it 2 minus square root of 2 over 4 times the square root of 6. And we're going to add to that. So we have 3 square root of 3 square root of 3, which becomes 3, which becomes negative 6 over 4 square root of 6. Adding these together, we're going to get negative 4 minus square root of 2 all over 4 square root of 6. Negative 4 minus square root of 2 over 4 square root of 6. Okay, seems a little bit odd, but maybe quite possible. All right, so for the next row, we're going to do negative square root of 3, negative square root of 3 over 2 times negative 2 plus square root of 2 over 2 square root of 6 plus negative 1/2 times negative 1 over square root of 2. And to get these into a common denominator, we're going to multiply by 2 over 2. That way we get this extra 2, and we're going to do a square root of 3 over square root of 3 to get that square root of 6. Yep. And so then this top part is going to be 2 square root of 3. So negative 2 times negative square root of 3 gives 2 square root of 3 minus square root of 6, because square root of 2 times, yep. And we're going to look at the other side. Negatives cancel. Plus 2 square root of 3. Okay, so we got 4 square root of 3s now. And we're going to be over 4 square root of 6. All right, simplifying this a little bit, we're going to have a total of 4 square root of 3 minus square root of 6 all over 4 square root of 6. We're going to factor out a square root of 3. So this is square root of 3 times 4 minus square root of 2 all over square root of 3 times 2 square root of 3. The square root of 3 is, this is supposed to be square root of 2. There we go. 3 times 2, 3 times 2. Yes. And this gives us 4 minus square root of 2 over 2 square root of 2. Copy and paste. Make a little bit smaller. Hopefully still large enough to read though. And then for the last one, it's going to be 0, 0, and then just the last value. So, in theory, this should be our new point P prime right there. So let's take a look and see what happened real quick. So what are the new coordinates P prime? And it's this monstrosity right here. All right, so now For part B, find the rotation matrix R such that P prime is RP for P prime we obtained in part A. All right, so for this, conceptually, what we have here, I'm going to grab this point P over here, move it over here. So we have this point P, and we want to rotate it by our matrices. Specifically, we want to do it in the order of X first, then Y, then Z. So if you think of this as kind of like a nested function, rotation on that, rotation on that, rotation on that. If you think about the size of these matrices, this is a 3 by 3 acting on a 3 by 1. That's going to give us a 3 by 1. This is going to give us a 3 by 1. And so our end result is again going to be a 3 by 1 matrix, which is just a point in 3D space. And we already have most of this data here, so what we're going to do is we're going to rewrite this as copy, paste, there we go. We're going to do our X rotation matrix, right, like so. Copy, paste. Then we're going to do our Y rotation matrix, which is right here. Get rid of that extra random 2. And then we're going to do our Z rotation, which we have down here. And so if we want to convert this rotation into a single matrix, we can look at the series of rotations as one rotation, because these are all 3 by 3 matrices. We can just combine these 3 by 3 matrices into a single 3 by 3 matrix. And so we're going to start with these two, and that's going to give us a 3 by 3. This gives us, oh, we could do it by hand. I'm not going to do it by hand. 3 by 3 matrices take a little bit more effort than I want to put into. Hop. And then we have that. So that's going to be our X and Y transformation. So now we're going to, and we still have our point over here, like so, copy, paste. So now we need to do this multiplication 2 to combine these two matrices, which gives us a final answer for P prime of this, which may or may not be the same as this one. Ideally it should be, but with this many mathematical calculations, I might have made a mistake somewhere. So ideally these two then would give us the same answer. So that's how you go through rotations. Hope that helped. I know lots of confusion. This is why computers do this. It's because it's easy to make mistakes. So hope that helped. See you next time.